In this video, I'll show you how to solve the ALEKS problem called counting significant digits when measurements are added or subtracted. To solve this type of problem, we're going to be doing either addition or subtraction problems, reporting our answer to the correct sig figs. To solve this type of problem, I think that it is easier to visualize if we stack the numbers up just the same way that we learned how to do when we were in elementary school. So stack them up like this. I'm going to leave the units off just to keep things simple. And let's use the calculator to do the math here. 9.60 minus 3.777. The answer I get from the calculator is 5.823, and the question is, how many significant figures are we allowed to keep when we're reporting our answer to this? So to help us figure this out, we're going to start on the right-hand side of the answer. We don't want to start on the left-hand side. We're going to start on the right-hand side. We're going to go through the digits one at a time, starting with the 3. We are only allowed to keep a digit if a digit in that place was present in all of the numbers that we were adding or subtracting together. So for example, this 3, we're not going to be allowed to keep it in our answer because there was no number in this position in the 9.60. Now we maybe could say, let's assume that that was actually a 0 there, but we're not allowed to do that. If no number was written in this particular spot, then that means we are not going to be allowed to keep that number in our answer. The 2 we are allowed to keep because there was a number in that place in both of the numbers that we subtracted with. There was a digit in that place in both of the numbers that we subtracted. And once we find that first digit, reading from right to left, once we have found a digit that we are allowed to keep because it was present in both of the numbers or all of the numbers that we added or subtracted, then we know that we are allowed to keep every digit to the left of that. Right? So once we have found one of them, we can keep everything beyond that. And so our answer for this is 5.82. Let's practice with our next one, 17.627, and we're adding 7.7. Let's take a look at what we get on the calculator. 17.627 plus 7.7 is 25.327. We're not allowed to keep the 7 because there's no number here. We're also not allowed to keep the 2 because there's no number here. We're only allowed to keep these numbers, which is 25.3 milliliters. Now, I do want to kind of add that in neither of the examples that I've done so far, I haven't had to do any rounding. Let's see if we have to do any rounding on the last one. So the last problem that we have is 10.500 plus 4.8. 10.5 plus 4.8 is 15.3. We are not allowed to keep the 0 because there's nothing here. We're not allowed to keep this 0 because there's nothing here. We're only allowed to keep these 3. So the answer is 15.3. And again, didn't have a chance to do any with rounding, but let's talk about that really quick. Let's pretend like it was 10.590 instead of 10.5, in which case this would be the answer that we got. We would not be allowed to keep this digit or this digit for the same reason. There's nothing in these spots. So these two numbers we would need to get rid of. But for this digit, because the one previous was a 9, we would need to round that 3 up to a 4. So same type of rounding rules apply when we're dropping digits off. If we need to round because the digit one of the digits that we're dropping is 5 or greater, then still do that. Do your normal rounding rules.